Hello students, today we'll discuss IB Physics HL Paper 2, May 2021, Time Zone 1. In this paper you should use calculator not to make mistakes and to be accurate. My name is Neriman Meryem. I'm located in Baku and here you can see my mobile and email. To prepare for the exam you need main huge textbook from Oxford 2014, short textbook from Tsokos, by Tsokos, or for revision and quick reference, Tim Kirk book 2014. When you are working with past papers already, you need physics data booklet 2016 copy, and also I recommend you to have physics guide 2016. Let's start. So this exam took place on Monday 3rd, 2021 and it lasted for 2 hours 15 minutes. Let's see what we have. Question 1. Two players are playing table tennis. Player 8 hits the ball at height 0.24 meters above the edge of the table, measured from the top of the table to the bottom of the ball. The initial speed of the ball is 12 meters per second horizontally. Assume that air resistance is negligible. Shows that the time taken for the ball to reach the surface of the ball is about 0.2 seconds. So this is projectile motion. Horizontally it moves at constant speed. And vertically it moves with acceleration g, 10 meters per second squared. A shows that the time taken for the ball to reach the surface of the table is about 0.2 seconds. So I refer to the data booklet, section 2.1, give us formula for displacement, and vertical velocity initially is 0. Total displacement should be 0.25. G is 10 meters per second squared if we consider downward. Solving this for t, we get 0.22, which is about 0.2 seconds. Sketch on the axis a graph showing the variation with time of the vertical component of velocity of the ball until it reaches the table tennis. Take g to be plus 10. So this is the graph. We start with time 0, speed 0. Then we use formula for how velocity is increasing vertically. So every second, so it changes at. So we take 0.2 seconds. For 0.2 seconds, it becomes 2 meters per second. So we plot another point, and because gradient equals acceleration, it is constant, we draw straight line. Finished. Question C, part C. The net is stretched across the middle of the table. The table has length so much and the net has a height of so much. Shows that the ball will go over the net. So first of all, let us consider the time it takes the ball to reach the net, not touch, but reach the position of the net. So distance is half, and we divide by speed or horizontal speed, we get 0.114 seconds. Then let's send y-axis downwards, actually not downward, upward, starting from 0. Then coordinate of the ball will be initial coordinate plus displacement. Displacement will be negative because we choose upward direction positive, y coordinate positive. I can sketch it here. Just a moment. So y coordinate. We have initial coordinate, we have displacement. The displacement will be minus gt squared. and over this time, so when it is above the net after 0.114 second, the height will be 17.5 centimeters, which is higher than 15 centimeters, so ball goes over the net. Finished. B. The ball bounces and then reaches peak height of 0.18 meters above the table with a horizontal speed of 10.5 meters per second. The mass of the ball is 2. Determine the kinetic energy of the ball immediately after the bounce. Immediately after the bounce, all energy is kinetic, but after some time, it goes up and part of energy turns into potential energy, part of into kinetic energy, but total stays the same. So we will use this idea. So mass we change into kilogram, height into it's given. So kinetic energy formula we take from subtopic 2.3. Just after bouncing, all energy is kinetic. Later on, total energy is kinetic and potential. So if we put these values, we'll get 0.15 joules to two significant figures. Player B intercepts the ball when it is at peak height. Player B holds a paddle, stationary or vertical. Stationary means doesn't move. The ball is in contact with the paddle for so much time. Assume the collision is elastic. Calculate the average force exerted by the ball on the paddle. State the answer to an appropriate number of significant figures. Note in the booklet we have the following statement. For elastic collision, relative speed of approach equals relative speed of separation. So the ball will bounce with minus 10.5 meters per second. So mass we change into kilogram, time is given. From subtopic 2.4 we have the force acting on the ball. It is rate of change of momentum. Momentum is mv. So change of momentum will be 2 times momentum at the beginning, before bounce. We divide by time and we get 5.7 Newton, and the same force act on paddle. So forces are equal and opposite. Question 2. A planet is in a circular orbit around a star. The speed of the planet is constant. The following data are given. Mass of planet, mass of star, distance from star to the planet. Explain why centripetal force is needed for the planet to be in circular orbit. So I took answers from mark scheme. Choose any of 2 of them and you are perfect. Calculate the value of centripetal force. Centripetal force here is gravitational force. So we use from subtopic 6.2 a formula for gravitational force. And this is centripetal force. So we calculate using calculator and we get 8.2 1023 Newton. C. Spacecraft is to be launched from the surface of the planet to escape from the star system. The radius of the planet is so much. Show that the gravitation potential due to the planet and the star at the surface of the planet is about minus 5. Okay, so radius of star is given. Potential is scalar. So potential due to planet will be r is radius. Potential due to star will be r is distance to the star, to the planet and spacecraft. So total is the sum. So we add and we get this value. Estimate the escape speed of the spacecraft from the planet system. So to escape, total energy should be positive. So it It means that kinetic energy should be greater than potential energy by absolute value, because potential is negative. So rewriting this formula for V squared and then taking square of both sides, we get this value. So question is done. Question 3. A mass of 1 kilogram of water is brought to its boiling point of 100 degrees Celsius using an electric heater of power 1.6 kilowatt. AI. The molar mass of water is 18 grams per mole. Estimate the average speed of water molecules in vapor produced. Assume the vapor behaves as an ideal gas. So first we change temperature into Kelvin. We use Avogadro data from booklet. Subtopic 3.2 tell us that average kinetic energy equals C2 Boltzmann constant time temperature. On the other hand, it is kinetic energy of particle, molecule, half mv squared. Right. To find mass of particle, we divide molar mass by number of Avogadro. Right. So okay, so let's see. So if we have half mv squared, estimate the average speed of water molecules. So to find mass of molecule, we should divide molar mass. It has nothing to do with the amount of water, so it depends only on temperature. So this is why here we don't have mass. We have only molar mass divided by number of particles, and we get so much. That's correct. State one assumption of the kinetic model of an ideal gas. So read these ideas from Mach scheme and choose one of them. So you can pause and read. B. A mass of 0.86 kg of water remains after it has boiled for 200 seconds. Estimate specific latent heat of vaporization of water. State an appropriate unit for your answer. So mass boiled will be difference. So this happened during 200 seconds. So power we change into watt. Not in the booklet we have formula for power. It is energy over time. It means that energy equals power by time. From subtopic 3.1 we get formula energy Q, here Q, because it is heat energy, equals ml. So Q we find Q equals E. So PT equals ml, L equals PT over m. We put numbers and we get the value in joule per kilogram. Why the temperature of water remains at 100 degrees during this time? So again I use answer from Mach scheme, and all energy added is used to increase the intermolecular potential energy of the particles. So temperature doesn't change, kinetic energy of particles doesn't change, so all is used to increase potential energy because atoms are separated, so potential energy increases. Part C. The heat is removed and a mass of 0.30 kg of pasta at minus 10 degrees Celsius is added to the boiling water. Determine the equilibrium temperature of the pasta and the water after the pasta is added. Other heat transfers are negligible, and information about specific heat capacity of pasta and water is given. So heat leaving water equals heat entering pasta. Subtopic 3.1 give us formula for energy change. Using 2 for water and pasta, we rewrite equation 1 using 2. Then we substitute amount of mass of water. C of water is 4.2, C of pasta is 1.8, mass of pasta is 0.8. Temperature change for water is this decreasing from 100 to T. For pasta it is increasing from T to from minus T to T, so T minus minus difference. Then rearranging formula, finding T, we get for two significant figures, 86 degrees. The electric heater has two identical resistors connected in parallel. The circuit transfers 1.6 kilowatt when switch A only is closed. The external voltage is 220. Shows that each resistor has resistance of about 30 ohm. So power is given, we change into watt. Subtopic 5.2 gives us formula for power with voltage and resistance. We rewrite this formula for resistance. We put voltage and power, and we get to two significant figures, 30 ohm. Done. Calculate the power transferred by the heater when both switches are closed. So method 1, we find total resistance. It will be 2 times less, and we get 2 times more power. Method 2, parallel connectors, identical resistors are the same, increase power 2 times. So nothing changed when they work independently, the switches and resistors. As a result, if one gives power 1.6 kilowatt and others do the same, we add powers, we get 3.2 kilowatt. Question 4. A planet orbits at a distance d from a star. The power emitted by the star is P. The total surface area of the planet is A. Explain why the power incident of the planet is this expression. Surface area of the planet is given. So if we take a planet, surface area is 4 pi r squared. It means that pi r squared equals A over 4. This we will need. Power radiated by the star on unit area at distance d is P. So from star, P is energy per second, and it is spread over surface area, 4 pi d squared. So for every meter squared, we have pi 4 pi d squared, and here how much is area so Earth is getting this energy on area of pr squared, but pr squared is A over 4, so we multiply these two parameters and we get the value that is needed. The albedo of planet is alpha P. The equilibrium surface temperature of the planet is T. Derives the expression where E is emissivity of the planet. This is a bit complicated question. Let's do it. So subtopic 8.2 gives us formula for power emitted by a body with temperature T. Albedo is scattered power by incident power. So rewriting this formula, we get scattered is Lp by incident. Incident power, as we calculated before, we have this formula. Incident power is this expression. Now, incident power equals scattered plus emitted. Incident we have scattered plus emitted. Scattered we have alpha P times P. Emitted is this formula, so we add. We write the expression, rewrite this formula for T over 4 and take fourth root of this expression, so this is done. By the way, sigma is Stefan Boltzmann constant. On average, the moon is the same distance from sun and earth. The moon can be assumed to have emissivity 1, albedo 0.13. The solar constant is so much. Calculate the surface temperature of the moon. Here, be attentive. Pi 4pd squared is solar constant. It is how much is falling on meter squared at the distance from the Earth, at the distance of the Earth. So we have solar constant. So this we put, so pi 4pi d squared. So we write this formula in this way. So this is, so here we have so first factor is solar constant, then 1 of alpha pi 4e sigma. So we put all values and we get 270 Kelvin. Question 5. A device sends an impulse of electrical energy to maintain a regular heartbeat in a person. The device is powered by alternating current AC supply connected to a step-up transformer that charges a capacitor of capacitance 30 microfarad. Explains the role of diode in the circuit when the switch is at position A. So diode lets the current to flow only the indicated direction. So conventional current will be going anti-clockwise, and conventional current is assumed that we assume that potential charges are moving. So as a result, this plate will be charged positively, upper part negatively. The voltage across the primary coil of transformer is 220. The number of turns on the secondary coil is 15 times greater than the number of turns on the primary coil. Shows that the maximum energy stored by the capacitor is about 160 joule. Voltage increase because of step-up transformer 15 times and becomes 3300 volt. Subtopic 11.3 give us energy of a capacitor. So we change microfarad into farad, substitute values, and we get two significant figures, 100 joule, 60 joule. Calculate the maximum charge stored in the capacitor. So from subtopic 11.3 we have formula for linking capacitor charge and voltage. We write this formula for charge. We get the value of 0.099 coulomb, which is two significant figures. Identify using the label plus on the diagram the polarity of the capacitor. As I told you, conventional current is indicated by arrow, so lower plate is positive. Part C. The switch is moved to position B. Describe what happens to the energy stored in the capacitor when the switch is moved to position. The energy stored in capacitor is delivered to the resistor, turns into heat. Actually, a capacitor is discharging, right. Shows that the charge remaining in the capacitor after a time equal to 1 time constant of the capacitor will be 0.37 coulomb. So from subtopic, I don't know which, the charge will be decaying according to this formula. So after time constant t, we have e to the power of -1, which is about 0.37. So this expression we got. The graph shows the variation with time of the charge in the capacitor that is being discharged through the hat. Determines the electrical resistance of the closed circuit with the switch in position B. Subtopic, so this is how the charge is discharging. From this graph we can find value of time constant, because before we learned that it happens after time constant the charge decreased to value 0.7. So we find value 0.737 at 1.6, somewhere here approximately, and it corresponds to 1.6 milliseconds. So 1.6 milliseconds is time constant. We divide by charge 30 microfarad and we get 53 ohm. Part D. In practice, two electrodes connected to hot circuit to the hot connect the hot to the circuit. These electrodes introduce additional capacity. Explains the effect of electrode capacitance on the discharge time. So electrode capacity is connected in parallel, so total capacitance will increase, resulting in an increase of discharging time, because discharging time is product of total capacitance by time. Question 6. Question 6. A painting is protected behind a transparent glass sheet of refractive index N glass. A coating of thickness omega is added, actually this is W, is added to the glass sheet to reduce reflection. Refractive index of coating is such that N glass is more than N coating, more than 1. The diagram illustrates rays normally incident on the coating. Incident angles on the diagram are drawn away from the normal for the clarity. States the phase change when a ray is reflected at B. At B, ray meets denser material, so phase change will be pi or 180. Remember this. Explains the condition for W that eliminates reflection for a particular light wavelength in air. Eliminate means that we have destructive interference. So phase change at A is also pi, at B is pi, and then phase change is only linked to the travel of light inside this coating. So 2 W should be equal to m plus half wavelengths, and they need condition for wavelengths, for width. So we rewrite this for also we should change lambda coating will be less than lambda in air by n of coating. So after using these formulas from subtopic 4.2, so speed is decreasing by n and lambda is decreasing by n, so lambda is lambda air over n coating. So putting this lambda coating into this formula, we have condition for omega. States the Reynolds criterion for resolution. Central maximum of one diffraction pattern lies over central minimum over the other diffraction pattern. The painting contains a pattern of red dots with spacing of 3 mm. Assumes the wavelength of red light is 700 nanometers. The average diameter of the pupil of human is 4 mm. Calculate the maximum possible distance at which these red dots are distinguished. So from subtopic 9.4, we know that resolution, topic is called resolution. We know that angle at which we see central minimum, first minimum of diffraction, we can calculate this minimum. It's very small, 10 times 10 minus 4 radians. So from trigonometry, we can say that tangent theta is theta equals d over small d over capital D. Capital D is distance that we need after rewriting and putting, so d is distance between spots, and at the same time we imagine that minimum of one is at maximum of another. So after calculation we get 14 meters. Question 7. Radioactive uranium produces a series of decays ending with stable nuclide lead. The nuclides in the series decay by either alpha or beta minus processes. Uranium-273 decays into nuclide of thorium. write down the complete equation for this decay. So we write decay equation, putting unknown x, y, and z. First of all, top numbers are balanced. From this we realize that y is 4, and 4 is for alpha particle. So bottom is 2. So putting bottom 2, we get bottom number for thorium, so x equal 90. So we have 90, 4 and 2, alpha particle. Thallium decays into lead. Identifies the quark changes for this decay. So if we look here, we see that number of protons increase by 1. So it means that one of the proton turn into neutrons turn into proton. Looking into subtopic 7.3, we realize that in this case, down quark turns into up quark, increasing charge by 1 electron, by +1. Or you can consider complete set of quarks of neutron change into complete set of quark of proton. The half-life of uranium is 238. Is about so many years. The half-life of thorium is so many minutes. Compare the contrast methods to measure these half-lives. So I copied the answer from MaxChem, so pause and look at these answers. So for okay, right. D. The graph shows the variation with nuclear number of binding energy per nucleon. Outlined why high temperatures are required for fusion to occur. So I copied answers from MaxChem. Links, so temperature is linked to kinetic energy. So higher temperature means higher kinetic energy, and energy is required to overcome Coulomb's electrostatic repulsion. Outline with reference to graph why energy is released both in fusion and in fission. Energy is released when binding energy per nucleon increases. So if we take for example, two nucleus from the on the left from the maximum, so they have less binding energy than top. So when they combine, we move to the right and binding energy per nucleon increase. If we take two nucleons from the left of the maximum, again, if they combined, we move to the fission. So one nucleus here divides into two smaller nucleus, so we move to the left, and binding energy of each of two products will be greater. So binding energy increase. In this case, energy is released. Why? Because binding energy is actually negative. So increasing binding energy means that total energy should not change. So part of energy should be positive. So it is positive in the form of kinetic energy of particles. So extra energy is released. Uranium-275 is used as nuclear fuel. The fission of uranium-235 can produce krypton and barium, determined in mega electron volt, and using the graph, the energy released by the fission. So using the graph, we can find, so we have 235 nucleons for uranium-275, chromium 89 nucleons, barium 144. So we find these values. For example, uranium-235 we find here, and we find how much is binding energy. So binding energy from this graph for this nucleus is 7.6. In the same way, we find energies, for example, chromium 89. Chromium 89, so we'll find somewhere here. It will be 8.60, 8.6 something, 8.6. Yeah, so I use answer 8.6. And barium 144, 144. It is somewhere in here, so 8.44, 8.3 something. So here I use 8.2. So then we multiply average binding energy by number of nucleons, and we see that the difference is 160 mega electron volt. So the values here are given in mega electron volt, so no problem. Question 8. On a guitar, the strings played vibrate between two fixed points. The frequency of vibration is modified by changing the string length using a finger. The different strings have different wave speeds. When a string is plucked, a standing wave forms between the bridge and the finger. Outline how a standing wave is produced on the string. So I took answers from Max Kim. So we have two ways. One is traveling wave and another is reflected from the edges, from the fixed end. Superposition gives us standing wave. Superposition of the reflection is reinforced only for certain wavelengths. The string is displaced 0.4 centimeters at point P to sound the guitar. Point P on the string vibrates with simple harmonic motion in its first harmonic with a frequency of 195. The sounding wave of the string is 62 centimeters. Shows that the speed of the wave of the string is about so much. So amplitude is so much. We don't need amplitude. F1 is given, length is given. Between two notes for fundamental frequency we have lambda over 2. So lambda is 2 lengths, so much. So we use subtopic for 2 for speed, and speed is 242 meters per second. Sketch a graph to show how acceleration of point P varies with its displacement from the rest position. Subtopic 9.1 gives us relation between acceleration and displacement. So it is straight line with negative gradient going to 0. Calculate in meters per second maximum velocity of vibration at point P when it is vibrating with velocity of 195. So amplitude is 0.4 centimeters. We change it into meters. From subtopic 9.1 we realize that amplitude of velocity is omega over amplitude of displacement. Omega is 2 pi f, f is frequency, and we put numbers and we get the speed. Calculate in terms of g the maximum acceleration at p. Again, from topic 9.1 we can calculate amplitude of acceleration, and we divide by 10 and multiply by g to find in g, because g equals 10. This is the answer. Estimate the displacement needed to double the energy of the strings. From subtopic 9.1, total energy is given by this formula. And we, so squaring both sides, we realize that amplitude of displacement is proportional to square root of total energy. So to increase total energy 2 times, we need to increase amplitude of displacement by square root times. So 0.4 by square root of 10 give us so many centimeters. The string is made to vibrate in its third harmonic. State the distance between consecutive notes. So first harmonic we have node, antinode, node, so nodes at the end. Then we insert one more node, we get second harmonic, node, antinode, node, antinode, node. Then we insert one more node, we get third harmonic. So node, antinode, node, antinode, node, antinode, node. So for the length we have three distances of nodes. So we divide length by 3, we get distance between two nodes. Question 9. Conservation of energy and conservation of momentum are two examples of conservation law. Outline significance of conservation law for physics. So I copied answers from Mark's scheme. Look at them. I don't want to stop here. So let's go on. Question B. So you can pause and look. So question B. When a pi meson and proton collide, a possible outcome is sigma baryon and Chiron meson. Apply 3 conservation laws to show that this interaction is possible. So I have smart method and straightforward method. Smart method, so we put the quark structure, then we combine, we add identical quarks, then we cancel quarks, and we cancel quark and anti-quark. As a result, as if we have up quark turns into up quark. So conservation of charge, yes, 0 to 0, baryon number, yes, 1/3 equals 1/3, strangeness 0 and 0. Straightforward method, you should use subtopic 7.3 table for charge, here mistake, charge, baryon number and strangeness for quarks, so you can add and show. So this is a requirement of Mach scheme. 3 correct conservation law listed, so we have 3. At least one, all 3 conservation laws should be correctly demonstrated. I demonstrated by smart method, you can demonstrate by straightforward method. Question 10. In an electric circuit used to investigate photoelectric effect, the voltage is varied until the reading in the ammeter is 0. The stopping voltage that produces this reading is 140 volt. Describe the photo effect. Again, I use answer from Mark's scheme. Electrons are ejected from the surface of a metal after gaining energy from photon. There is minimum threshold energy, maximum threshold, or maximum threshold 3. So any 2 ideas from this. Shows that the maximum velocity of the photoelectrons is so much. So stopping voltage is so much. Subtopic tell us that maximum kinetic energy of electron is so much. Stopping energy is equal to the maximum kinetic energy. So because we are able to stop moving we are able to stop electrons, photoelectrons, to reach another electrode. So subtopic 2.3 give us formula of kinetic energy. So using 1 and 2 we have, so kinetic energy equals electrical energy. We write this formula for V. We put values using data information for electron and mass of electron. We get 700 kilometers. Part C. Photoelectrons are emitted from a sodium surface. Sodium has a work function of 2.3 electron. We calculate the wavelength of radiation incident of sodium. State an appropriate unit for your answer. Subtopic 12.1, maximum kinetic energy. So energy of photon is maximum kinetic energy plus work function. So we can calculate right part in electron volts. We get 3.7. Then electron volt is charge of electron by volt, so 1610 minus 19. So we have energy in joules. On the other hand, subtopic 7.1 give us formula for lambda of some photon with energy E. So we put energy E, H Planck constant, C speed of light. We get these values from data booklet and we get 3.4 10 minus 7. Paper is over. Thank you for your attention. See you next time.